Okay, so we'll start by looking at the calendar briefly. Today we talk about roots and radicals and rational exponents. We've been doing exponents for like 3 classes in a row now. Today's the 4th one. Next class we start doing something kind of different. We'll work with some more radicals, but we'll also talk about products of binomials. And then we start factoring, which is kind of a big topic that many of you I'm sure have seen before, factoring trinomials. And it's still a little ways away, but just want to give you a heads up that our 3rd quest is coming up on November the 5th. Questions on the calendar? Okay, so I think November 5th is a week from this coming Wednesday. That's when our next quest is, all right? November 5. Okay, so we're here on the top of page 19. And we'll start with the daily summary. Can we go to Dan? Yes. Okay, thank you. Normally we'd stay at the table, but we've got Jasper's rules, so we'll let Jasper read number 1. So here are the symbols that we've called Jasper's rule. If you take the nth root of x to the k, you get to take those powers and divide them. K divided by n becomes the new power. We saw that last class, and we saw it last class in every single one of them. The power, this guy right up here, was always a multiple of that guy, the index. And so when we did the division, we just got a nice whole number, 21 divided by 7. And this guy turns out to be x to the 3rd by just dividing. So today we're going to see cases where where the power is not a multiple of the index, but it turns out the rule is still valid even if the number doesn't go in evenly. So if we take a look at this example here, the 5th root of x to the 8. So normally we would take the 8 and divide it by the 5. And last class we said, well, shoot, that doesn't go in evenly. But this class we say, well, that's okay. The rule is still valid, and the answer is just x to the 8 over 5. And really, there's only like one way to get this kind of problem wrong, and that's to not know that this guy goes on top and this guy goes on the bottom. It's really just a matter of you have to divide in the right order. And so again, another silly mnemonic device coming your way. Okay, so the index, we have to know what the index is. Which one is the index, the 8 or the 5? The 5 is the index and the 8 is the power. We saw those words last class or 2 classes ago. So the index goes below deck. If you imagine the power is like a ship and it's got a top and a bottom, and so the index goes below deck. I'm sorry, I'm not saying these are good mnemonic devices, right? I'm saying it's just something. Get like all these looks from you guys. It's just like, okay, and then the power. So how do I know the power goes up there? So I'll say that flowers grow up, and so powers go up. Powers go up. I'm doing the best I can with what I have. So let's try number 3. Here we go. Flowers grow up, powers go up. Okay, so we take negative 2y. It was in parentheses before. It needs to be in parentheses now. And the choices are either 11 over 13 or 13 over 11. Which one is it? 13 over 11. That's it, right? There's only one way to get this wrong. That's to flip the thing over. So just have to know where the pieces go. And then number 4 asks us to go the other direction. We take the power and we'll write it as a radical. So I'll write my radical. I'll write my x. And then we just have to know where the things go. So is the 2 the little index in the front, or is the 2 the power? 2 is the power, because we know that the powers go up, grow up. 2 is there. And the 7, the thing that was below deck, must have been the index. Okay? All right, so then we get to some numerical stuff like this one here, number 5. Has 64 to the 1/2 power. So all of a sudden, we're going to need to be able to recognize what these fraction powers really mean. So this means a radical of some flavor. I know that because it's a fraction power. Where does the 1 go? Is it the index or is it the power? The 1 is the power, and the 2 is the index. And so this problem, 64 to the 1/2, is really just asking us for the square root of 64. That's it. And what is the square root of 64? It's 8. And so it's just a matter of not being intimidated by these powers, even though they're fractions. A 1/2 as a power just means square root every single time. And then what if we have this guy, negative 64 to the 1/2? So I guess we've decided that it must just mean this, right? Square root of negative 64? What is the square root of negative 64? Yeah, so it isn't negative 8 because negative 8 times negative 8 doesn't give you negative 64. So at the moment, all we can say is that this is not real. We don't have a number yet that we can use to answer this, but Julie is exactly right. The answer is imaginary, and we'll talk about those later this semester. And then finally, part C. So I'm going to write the square root of 64 to the first power again, and then I'm going to ask you where that negative sign goes. Does that negative sign go in the front of the radical or inside the radical? It goes in the front. Well, remember that powers are very weak and they don't have very much reach. And so there's kind of these invisible parentheses that say, take care of this numeric calculation and then slap a negative in the front. So what's the answer to this problem? Negative 8. That's it. Okay, number 6 says we're going to do one problem in 2 different ways. 8 to the 2/3 is what we're asked to calculate. 8 to the 2/3. So I see a fraction power. I just start with a blank radical. And the number that goes in the radical is 8. How about the 2? Is it in the front of the radical or is it the power? It's the power inside, which means this is really what kind of a root? Cube root. Okay, so we've done our translations. And now 8 squared, we just have to do that calculation. That's 64. And then the cube root of 64. And if you don't know it, the cubes are, where are they? Over there, the green numbers. So if we can just find the 64 in the bottom row, say, oh, the cube root of 64 is just 4. So that's the answer to this problem. 8 to the 2/3 is 4. You don't need to do this on your calculator right now, but your calculator is programmed to understand what fraction powers mean. So if I type in 8 to the 2/3, just like that, what should we get? We should get 4. What did I do wrong? It's parentheses, because 2/3 is one thing, and the calculator doesn't realize. The calculator did 8 to the 2. Order of operations says do 8 to the 2, 64, and then divide by 3. That's what this is. So I should have typed in 8 raised to the parentheses 2/3, and now it will give us the right answer of 4. Okay, so I said we were going to do this in 2 ways. So here's the second way. I'm going to do it this way. I'm going to write 8 there. What's the index still? It's 3. And normally we've been putting that number on the top as the power inside the radical, but I'm instead going to put it out here, and then I'm going to put extra parentheses to really make it clear that we're going to try doing that power last. Now it shouldn't be clear that this is going to work, but it's just something we're going to try. And in some sense, it's kind of reasonable. We said that the 2 was the power. We didn't really specify it had to be the power inside, right? Maybe it'll work to put the power outside. So what is the cube root of 8? It is 2, and then it's still supposed to be squared, and 2 squared is 4. And it worked, and it wasn't a fluke that it worked. It will always work. And so in which of these 2 problems did the numbers stay smaller the whole time? It's the second one, right? The 64 is not all that big, but you can imagine that there might be problems where the number would get really big before it kind of came down to size. And since they both work, I would recommend that if you're going to have to do a calculation by hand, you use the second idea. And so that's down here in number 8. It says, okay, if you see x to a fraction, you can either write it like that, or you can write that power on the outside. And so I'm just going to highlight this second equal sign because that's the one that I use most of the time. If I'm doing a calculation, I use that. All right, and then last example for today is number 9. Says we're going to make things even more complicated by throwing a negative into the exponent. So 16 to the negative 3/4. It's a negative exponent, and it's also a fraction exponent. Oftentimes, here's my suggestion for the good first step, is deal with that negative exponent first. So let's deal with the negative exponent first. If you see a negative exponent, what does it mean? What's our definition of a negative exponent? One over 16 to the 3/4. We're not flipping the power. We saw a couple of, maybe it was last class, we saw that if you have a negative exponent, it just means 1 over the thing to the positive exponent. So you don't change the 3/4, you just make it positive. So that's how we deal with the negative, and that's that. And then 16 to the 3/4, well, 3/4 is one of the new things that we've seen how to deal with today. If I see a fraction power, what symbol do I start with? I start with a radical sign. Fraction means radical. I've got a 16 in here. How about the 3? They go in the front or the power? Goes as the power. I'm going to put it here, but I suggest you not copy that just yet. Where does the 4 go? Out in the front. So it's the 4th root of 16 cubed. Now, if you have a calculator, it's not that big a deal to type in 16 cubed, but if you're taking a quest without a calculator, then this is not the best way to solve this problem. I don't remember. I don't know whether or not the quest coming up is calculator active. But what we've decided is that that power, instead of going inside, could just as well go outside, right? So it was the same. And so I'd much rather do the problem this way than the other way. So this equals 1 over, so I've got some stuff that's still going to be cubed. What is the 4th root of 16? It's 2. So that becomes just 2 cubed, which is a whole lot easier than the 16 cubed, which we were asked to do before. So this is equal to 1 over 8. Just for kicks, let's try that 16 cubed thing just to make sure it would have worked the other way. So if we do 16 to the 3rd power, I'm going to do this in my head, hang on, 4096. Yeah. It turns out it's just one of the blue numbers up there, yeah. So a very quick detour. 16 is the same as 2 to what power? 2 to the 4. So then 16 cubed is really 2 to the 4 cubed. What do we do with the 4 and the 3 when they look like that? We multiply them, so 2 to the 12. And these blue numbers are the powers of 2. So well, that's not what I did. I did 16 cubed in my head, but you could do 2 to the 12 on the board over there. Okay, and then, so if this were the answer, then 4096 would be, this is what we thought we were writing initially. We were really writing this, 16 cubed here. 4th root of 4096. And it's still not easy. I don't know what the 4th root of 4096, well, I do, because I'm really smart. It's 8. But if you don't know that, then you have to do work. Number 5, what is it? 4096. I think it's 8. 8. Good. What's right there? Oh, look at that! It is right there. Yeah, I hadn't realized that. Right. Yeah. So anyway, so you can see that doing that power on the outside is a whole lot easier if you don't have a calculator with you. All right. Okay. So the activity starts on the next page. I believe that there's plenty of time to get through the entire activity and get a good start on your homework. So let's see how far we can get.